So the next part of derivatives is arguably the most important rule, and this is called the chain rule. So the idea behind the chain rule is, how do we take the derivative of something like x squared minus 4 to the 5th power? Now what we could do is actually multiply this all out and use the power rule, or we could separate it and use the product rule, but those are going to take a long time to do. So how do we take the derivative of something like this? And that's where the chain rule comes in. So what the chain rule is a rule to take the derivative of composite functions. So what a composite function is at least two functions that are composed. So let's just state the chain rule. It says that the derivative of f of g of x is f prime of g of x times g prime of x. So this is the chain. I think it's actually easier to see the chain if we do three functions. So this is just two functions. Let's say I want to do the derivative of f of g of h of x. It would be f prime of g of h of x times g prime of h of x times h prime of x. So here I think you can more see the chain. We're going to take the derivative of the most outside function, keep our inside, times the derivative of the next inside function, keep the inside, and then finally times the derivative of the last one. So that's going to be the chain rule. Now how we're going to do this is write out our composite functions. So for example, let's look at our original function. X squared minus 4 to the 5th. Now you want to ask yourself here, if I was plugging in a number into this function, what's the first thing I would do? So if I wanted to figure out what is f of 2, what's the first thing I would do using the order of operations? The first thing I would do is calculate x squared minus 4. Then, what would I do? I would raise that number to the 5th power. So those are our two functions. So if you're going to plug in a number, what would you do? First thing you'd do is x squared minus 4. Usually the parentheses will give it away. Then you would take that number, raise it to the 5th power. So those are your two functions. Now to calculate the derivative, I'm going to start with the last thing that I wrote. And I'm going to say, what's the derivative of x to the 5th? That would be 5x to the 4th, but I'm not going to write x. I'm going to write everything that was above it. Now I've taken care of number 2. Now I'm going to multiply this by the derivative of the first one. So the derivative of x squared minus 4 is just 2x. So that's my derivative. So again, what did I do? I wrote out my functions, started with the last one, took the derivative, kept the inside part, so I kept everything above it, then multiplied by the derivative of the first one. Let's try another one. Let's find the derivative of 2e to the 3x. So can we do this derivative directly? Well, no, because I have a 3x here, not an e to the x. We know the derivative of e to the x, but not e to the 3x. If I was plugging in a number, what's the first thing I would do? First thing I would do is multiply it by 3. Next, what would I do? So now I've calculated my exponent. I would calculate 2e to whatever I got in the previous answer. So those are my two composite functions. Now start with your last function. What's the derivative of 2e to the x? That's 2e to the x, but I don't write an x. I write everything that was above it. Now move up one. What's the derivative of 3x? Just 3. So I get 6e to the 3x. Hopefully you're starting to see the chain here. Let's do the derivative of cosine of x squared minus x. So again, ask yourself, if I was plugging in a number, what's the first thing I would do? The first thing you would do is calculate x squared minus x. Again, the parentheses usually give it away. After you calculated that, you would then plug it into the cosine function. Now let's start with our last one. What's the derivative of cosine? That's negative sine. But I'm not going to write an x, I'm going to write everything that was above it. Now I've taken care of that one. Now I'm going to multiply it by the derivative of x squared minus x. I want to be careful with parentheses here. I'm multiplying it by the entire derivative of x squared minus x. So there's my derivative. Okay, how about f is e to the x squared plus 3x plus 2, and I want to find f prime of x. Again, can I do this directly? No, we only know the derivative of e to the x, not e to a polynomial. So if I was plugging in a number, what's the first thing I would do? I would calculate the number squared plus 3 times that number plus 2. Next, I would raise e to that power. Now let's start with the last thing you wrote down. What's the derivative of e to the x? It's e to the x, but I don't write x, I write everything above it. Now multiply this by the derivative of x squared plus 3x plus 2, so 2x plus 3. So there's my derivative. Okay, let's find the derivative of cosine squared of 3x squared minus 2x plus 1. If I was plugging in a number, what's the first thing I would do? I would calculate the polynomial here, 3x squared minus 2x plus 1. Then what would you do? Well, cosine squared, that means first find cosine of the previous number. And then after you find that, you would square it. So this is a chain of 3. So the first thing I would do is if I was plugging in a number is calculate this polynomial. That's my most inside function. Next, I would calculate cosine of that number, and then lastly I would square it. Let's start at the very bottom. What's the derivative of x squared? That's 2x, but I'm not going to write an x, I write everything that was above it. So everything that was above it was cosine of 3x squared minus 2x plus 1. So that takes care of my third one. Next, what's the derivative of cosine? That was negative sine, but I'm not going to write sine of x. I write everything that was above it. And then lastly, the derivative of 3x squared minus 2x plus 1 would be 6x minus 2. So there was my derivative. You can see this had 3 pieces because I had 3 functions. So I had my most inside, my next outside, so the middle one, and then the very outside one. So I started with the last one and worked my way up. Okay, how about the derivative of 2e to the x squared minus x to the third? I want to find the derivative of this function. So again, I'm going to write out my steps. If I was plugging in a number, what's the first thing you would do? You would calculate x squared minus x. So that would be this piece. Then you would cube that number. Then you would do 2e to that number. So I have 3 pieces here again. I'm going to start with the very last one. So the derivative of 2e to the x. That's 2e to the x, but I don't write an x. I write everything that was above it. So that was x squared minus x cubed. So I'm taking care of my third one. Next, what's the derivative of x cubed? That would be 3x squared, but I don't write an x. I write everything that was above it. So there's my 3x squared. And then lastly, the derivative of x squared minus x, 2x minus 1. And I'm going to be careful with parentheses there. So you can see my 3 derivatives. The part that's going to be confusing is keeping everything above it as your x. But I think you can kind of see the chain there. Okay, let's do a little bit of a longer one. How about 2 sine cubed of x cubed minus 2x to the 4th? So a lot of functions playing the part here. What's my most inside function though? The most inside would be the x cubed minus 2x. If I was plugging in a number to this function, I would do x cubed minus 2x, then I would raise it to the fourth power. Then what would I do? Well, this sine cubed, this says take sine and then cube it. So the next function would be sine of x. And then lastly, I would cube it and multiply by 2. So this time I have 4 functions, but hopefully you can see the most inside, x cubed minus 2x. Then I would raise that to the fourth. Then I would take sine of that number. Then I would multiply, or I'd cube it and multiply by 2. So there are my 4 functions. So let's do the derivative. Start at the bottom. What's the derivative of 2x cubed? That would be 6x squared, but I'm not going to write a 6. I'm not going to write an x, I'm going to write everything that was above it. So everything that was above it was the sine of x cubed minus 2x to the fourth. And remember, this is 6x squared, so sine squared. So that takes care of my first piece. So the derivative of 2x cubed was 6x squared. So here was my 6. All of this was my x, and then I squared it. Next, what's the derivative of cosine, or sorry, sine? That's cosine. But I don't write an x, I write everything that was above it. So that's x cubed minus 2x to the fourth. Okay. Next, the derivative of x to the fourth is 4x cubed, but I don't write an x. I write everything that was above it. And then lastly, the derivative of x cubed minus 2x, 3x squared minus 2. So there's my derivative. Okay. Let's do one more, or maybe a couple more here. Let's say that f of x is 5e to the x squared times x squared minus 3x. And I want to find this derivative. So this is 5e to the x squared times x squared minus 3x. So remember, as soon as you see the word times, you're going to think product rule. So I break it up into a u and a v. Let's find v prime first. So v prime is the derivative of x squared minus 3x, so 2x minus 3. But now what about u prime? So u prime is the derivative of 5e to the x squared. Well, that's a chain. First function is x squared. Second function is 5e to the x. So now I have the chain rule inside of a product. So what's the derivative of 5e to the x? That's 5e to the x, but I don't write an x. I write everything above it. And then times the derivative of x squared, so 2x. So the derivative of my function is u prime v. So let's see, what is that? 10x e to the x squared times x squared minus 3x plus u v prime. So just because we have the chain rule doesn't mean we can forget the product rule or the quotient rule. It just means that whenever we're finding u prime and v prime, we might have to use the chain rule. So let's do maybe one more example where I have to involve a quotient. Let's find the derivative of x squared minus 2 to the fifth over 3e to the x cubed. So here I have a quotient, so I'm going to let u be the top, and I'm going to let v be the bottom. I just have to find u prime and v prime, then I can plug it into the quotient rule. So first let's find u prime. To find u prime, you got to take the derivative of x squared minus 2 to the fifth. That's a chain. First function was x squared minus 2, second function is x to the fifth. So using your chain rule, take the derivative of x to the fifth, so I get 5x to the fourth. But I don't write x, write everything above it. Then the derivative of x squared minus 2 is 2x. Now I'm going to take the derivative of 3e to the x cubed. Again, that's a chain. First function, x cubed. Second function, 3e to the x. So the derivative of 3e to the x, 3e to the x, but I don't write an x, I write an x cubed. Next, the derivative of x cubed is 3x squared. Now I found my u, v, u prime, and v prime, so I plug it into my quotient rule. So the derivative is u prime v, so that's 10x, x squared minus 2 to the 4th, times 3e to the x cubed, minus uv prime, so that's x squared minus 2 to the 5th, times, and if I simplify this just a little bit, 9 and x squared e to the x cubed, all over v squared. So you might be asking, when do you use the chain rule? And the answer to that is always. You always use the chain rule. Even if you think your inside function is just x, that's fine. The derivative of x is just 1. So in the chain, it's not going to matter. But you always use the chain rule. So you might have to use it inside of a product or a quotient, but you always use the chain rule.